Welcome back to the ATO Automation channel. Today we're diving deep into a fundamental automation project, using a PLC and an HMI to simultaneously control the forward and reverse motion of two stepper motors via RS-232 communication. Let's get started. First, let's look at all the components you'll need, all available from ATO. You'll need a PLC, an HMI, two stepper motors and their corresponding stepper motor drivers, and a 24-volt DC switching power supply. And the following block diagram shows the basic architecture. Here's how it all works together. The HMI sends commands via RS-232 communication to the PLC. The PLC then executes its program, sending pulse and direction signals to both stepper drivers, which ultimately drive the motors. The following wiring diagrams will show the connections between the PLC, HMI, stepper motor drivers, stepper motors, and power supply. Follow along carefully for proper wiring. Wire the stepper motor drivers to the PLC according to the wiring diagram. Before powering on, we must configure the drivers using these dip switches. The settings depend on your motor's specs. For our demo motors, set the peak and RMS current dip switches to match the motor's current rating, say 2.84 amps and 2.03 amps. The microstep resolution is preset to 1000 pulses per revolution. Always consult your motor and driver datasheets for these values. With the hardware ready, let's configure the logic. Open the PLC programming software and set up communication between the PLC and HMI. Ensure the communication parameters like the brand name, COM port, and baud rate match exactly between the PLC and HMI. For a detailed tutorial on this setup, please see our video, HMI and PLC Programming and Testing, on our channel. The PLC program consists of two major logical sections. Forward start and stop, and reverse start and stop. When input W0.00 is triggered, we execute a SPED, speed output instruction. We set it for pulse output 0 in continuous mode at a frequency of 3000 Hz, so the motor rotates clockwise at that speed. At the same time, bit Q100.0 is set on. When W0.00 is opened, another SPED instruction is executed with a frequency of 0 Hz, stopping the motor. And resetting Q100.00 to off. The logic for reverse is identical, but triggered by W0.01, when input W0.01 is closed. The PLC outputs pulses at 3000 Hz for counterclockwise rotation. The same indicator logic applies, using bit Q 100.01 for the reverse status. Releasing W0.01 stops the motor by setting the frequency to 0 Hz. And resetting Q 100.01 to off. This program logic applies to both stepper motors. On the HMI interface, we've created two momentary buttons, forward and reverse. Link the forward button to PLC address W0.00. Link the reverse button to PLC address W0.01. This allows the operator to control the motors easily with a tap on the screen. Now let's see the system in action. Keep pressing the forward button. Both motors start synchronized rotation clockwise, moving the slides toward left at the same speed. And holding the reverse button initiates counterclockwise motor rotation, driving the slides towards the opposite direction. And releasing either of the buttons stops the motors instantly. Perfect! The system is working exactly as programmed. Ready to build this system yourself? You can find all the components featured in this video: the PLC, the HMI, the high-torque stepper motors, drivers, and power supplies on ATO.com. ATO.com is your one-stop shop for industrial automation solutions, offering great prices and reliable components for all your project needs. Whether you're working on precision motion control, factory automation, or experimental projects, ATO has everything you need to bring your ideas to life. Visit the links in the description below to shop these components and explore our vast catalog today. If you found this tutorial helpful, please like, subscribe, and leave a comment below. Thank you for watching, and stay tuned for more exciting industrial automation content.